Hello everyone, welcome to another coding session. In this session, we'll continue with Asyncio. I wanted to discuss with you one practical aspect of Asyncio, which I came across yesterday. So I thought I'll make a video on this. All right, so this is pretty real world. Let's get started. So I today I want to show you what happens if you're using Asyncio, but you get a third party library API which is not async, right? So you might be writing async code, but you might have APIs or libraries which do not have async implemented, or they are basically synchronous in nature. So how do you use those APIs or that library in your code? Okay, so this is a very practical example of what I faced and how do you solve it. So all right, so basically, I'm defining a data class called database. Now, this database has three parameters, connection, or three attributes: connection, loop, and executor. Connection is basically I'm using SQLite as my database. So SQLite provides a sync library API, but here I've used the synchronous version of it. So now the problem is when I create a connection to SQLite database, this is a synchronous API, but my database, my whole code is async, right? So let's move forward. I'll show you how do you solve this problem. Now I have a connection attribute. There's a loop which is async IO event loop, and then there's an executor. So this executor is ThreadPool Executor. Basically, ThreadPool you import from concurrent.future, concurrent.futures.thread in ThreadPool Executor. So these three things I'm defining as part of my data class database. Now I have a class method called connect, which is also a context manager. So this one is basically a class method. That's why I have CLS here. And so what I'm trying to do here is now I create an event loop, which is async IO get event loop, the main event loop, and then I initialize a thread pool executor. You can give number of workers here. I'm just giving one. So I get an executor, so what a thread pool executor is basically it takes your code and runs in it in a different thread. Okay, that's what executor does. But why do we care here? We care here because now what I do is I have this executor, and then your async IO provides something called run in executor. Now this is actually the function or the API that will solve your problem of async code. So what I do here is I do await async IO loop dot run in executor. I pass in the executor which I created, which is a thread pool executor. This run in executor functions, you can see, takes executor, it takes a function and a list of arguments to this function. So I pass in the executor, then I am calling this connect function which is defined here. Now this function takes a file as an argument, so that I pass it here. So in executor you can pass if the first in the function call you have to pass the first parameter is executor, then the whatever function you want to run, and then this thing, and then I do await. So now what happens is, why did I need to do this? Now look at this function called connect. Okay, in this connect function I'm calling SQLite.connect. Now this SQLite library is my async library. It does not have an async IO option. That's why now if I had called here without an executor, it would have blocked my async IO code, right? So it would have blocked my async code. That's the reason you put it in an executor. So what happens is the moment you put it in an executor, even though you are making a synchronous call as an async. So this is how you typically overcome the problem of synchronous code. The moment your Python encounters this line, it will push the execution in another thread, and your main async IO event loop doesn't block. So this will run in a parallel thread, so basically you're turning any code that is synchronous, you can turn it into a async code, right? So and then you can do await here. See, there is no await. This is not an async function, right? It's a normal function, but I can still call await when I run it in executor loop, and right. So basically I call this, and this is how you call it. You give the executor, which you have to initialize here, which I'm initializing here, then you pass in the actual function call and the argument of the function, right? And then once you get all of this, then you do uh, connection and then loop and executor. This is how I'm initializing a database object here, calling itself, and then I'm yielding itself. And since this is a context manager, I'm putting all of this in try finally. So once this is exits, once this exits, then I'm closing the connection. Now this is how you turn, and again the problem was because my SQLite library didn't have a async connect function. If I had it, I would have used that. But since this is a synchronous API of SQLite, I had to do this thing to make this code asynchronous. Okay, and then you can go through the, you can look at other code. I have another function which is pretty okay. So if you look at the so add message function, this function basically just adds message to the database, right? What I'm doing is, again, I'm, since writing into database is again a synchronous option, I'm again asyncifying it, right? So that's what I've mentioned here. So any synchronous option I can convert into asynchronous operation by calling on. So let's look at this function. If you look at this function definition, uh, it, it, this is my function that I've defined here. So it takes a function which I want to asyncify. Any, you can pass it any function. Then it takes the arguments to those function, which you can see p dot args, and then you can and then the key value arguments to that function. So I pass in the function, all the arguments is the function. The normal argument is the key value arguments, and then what I do is I have that loop, right? So loop dot run in executor. I pass in the executor, right? Whatever executor that I defined. Then and then the function and then the argument. So now the thing is, in run dot execute an executor, it takes an argument like this, right? So you have function and then you have arguments. You cannot pass key value. So I have to create a partial. I use partial to create a from functools dot partial. I create a partial function and pass in the key value arguments to it, so that I get a function, and then only the normal arguments without the key value ones, those I pass in. Yeah, so that's a small trick that you use to run this. Similarly, so you can, this function can be anything, right? So here in add messages, I'm passing self.execute function, and these are my arguments, and this is my key value argument. So all of this will be passed to the syncify function, and then execute is just a simple, it takes a connection and it executes whatever is whatever it basically just takes the execute is just a function that takes an arguments and commit, and then runs these arguments on the SQL, right? So you have current.x, it takes a SQL string and then the arguments in this, right? So it just runs SQL statement, and that is what it's doing here. Um, so yeah, this is what I wanted to share with you today. There is now, okay, there are certain technicalities to doing this, which is basically making sure that your thread does not uh, thread safety and things like that. I'll cover in another video, wherein let's say you have a thread, but from you want to now you want to do the reverse from your thread, you want to schedule some calls on the main event loop, right? So there are some thread safety issues, or you have to use basically APIs which are thread safe. Okay, but we'll cover that in another video. Another important thing is, you could why could you not use um, that is from concurrent dot. So if you see this, I have imported this. There is another option called, if I do this, process pool executor, right? Why am I not using process pool executor? um, there are, like, if you in async IO, if you're using queue and things like that, process pool executor does not guarantee you the locks of those queues, right? So because when you run process pool executor, your code gets serialized or pickled, and then the processes are run. It doesn't ensure so if you're sharing a common queue or something like that, then those queues are not process safe, right? So basically the lock on the queue will not be guaranteed, but if you thread pool executor, they are guaranteed. So yeah, I mean, this is what it is. We'll come to that. I'll make a video on some technicalities in the future. All right, so this is what I wanted to share with you. This is how you if there's if there's a synchronous code, this is how you synchronous you how do this is how you asyncify it and use it in your code. Okay. Um, all right, folks. I'll push this code on GitHub. Thanks for joining, and see you another time. Like, subscribe, and share it with your friends. Thank you.